All right. Recording, sharing screen again, just to let y'all know. I already started. So connecting transformations and z-scores. We are almost done. Shape is affected by nothing. Shape is affected by nothing. The shape of a distribution of z-scores would be the same as the original. Like we just learned, the center is affected by everything. So if we subtracting would reduce the center. Dividing would reduce the center to 0. This is key in z-scores. So the reason that we find z-scores is so we can normalize our data, and we have 0 as our mean. So that's what we want, is to have 0 as our mean.
How would dividing reduce the center to 0?
You'll see. Just bear with it, okay? All right, and then spread. Is affected by multiply and divide. Rachel, I'm jumping the gun on that, so we will go over why it reduces it to 0. Okay?
Okay.
Because that's going to be your distance from the mean, and we want it to be 0 to make it normal. But we'll get there. All right, dividing. Would reduce to 1. Okay, this is the other thing that we want to know. So our standard deviation, we want our mean to be at 0, and we want our standard deviations to increase by 1. 1 standard deviation above, 2 standard deviations above, 3. So that is what we're trying to do, is get to that standardizing point, which we will. Okay, so again, I'm jumping the gun, but this is what you want. You want your center at 0, and then you want all your standard deviations to be in 1, sets of 1. All right, so descriptive statistics, test scores, z-scores. So many other types of transformations can be used, can be very useful in analyzing data. We have only studied what happens when you transform data through addition, subtraction, multiplication, and division. So again, if you look right here, we have a test score of 80, but if we normalize it or standardize it, it drops that z-score to 0. So your mean would be at 0. Your standard deviation normally would be at 6.07, but when we standardize, it goes to 1. This is what we want. If you look, it makes it normal or symmetric because your mean and your median are exactly the same. Okay, so that's in the end what we're trying to do. We'll talk more about what it does and how it does that real soon, okay? So let's look at your check your understanding. This is the last thing that we're doing. The figure shows a dot plot of the height distribution of admission of arts class along with summary statistics from computer output. Suppose that you convert the class's heights from inches to centimeters. 1 inch, there's your conversion, equals 2.54 centimeters. Describe the effect this will have on the shape, center, and spread of the distribution. So what are we doing? When we convert, what do we have to do? Add, subtract, multiply, divide.
Multiply.
We're going to be multiplying. So what does that affect? That's what it's asking.
Center and spread.
So the shape does not change. So you could put no effect, does not change, that's fine. But it wants you to talk about all of them, shape, center, and spread. What's gonna happen to the center?
Be 2.54 the what it was before.
It will increase by a factor of 2.54. And what about your spread?
Same thing.
Yep. Increase by a factor of 2.54. Okay, so don't forget, multiply and divide affects shape, does not affect shape, affects center and spread. If Ms. Novard had the entire class stand on 6-inch high platform and then had the students measure the distance from the top of their heads to the ground, how would the shape, center, and spread of the distribution compare? So if you stand on a platform that's 6 inches tall, what does that do to your height?
Add 6.
So this is adding. And it wants to know, what does it affect? So shape, what does it do to the shape?
Nothing.
Yeah, nothing affects the shape. Does not change. The shape does not change. What does it do to the center if you add it? If you add it, what does it do to the center? Which way does it move it?
Up, like to the right.
To the right. And if you subtract it, moves it
To the left.
to the left. Okay, for this one, we're standing on a 6-inch platform. So what does it do?
Move to the right.
And you can just put increases by 6 units. You can put moves to the right by 6 units. That's the same thing. What about spread when you add or subtract?
Stays.
Does not change. Good. Now suppose that you convert the class's heights to z-scores. So we're normalizing it. What would be the shape, center, and spread of the distribution? So what would be the shape?
The same.
It's exactly the same. Nothing changes. If we're standardizing, where do we want our center to be?
0.
Yes, ma'am. And then where do we want our standard deviation to be, or our spread?
Is it the same?
Nope. 1. Again, what we're getting into, and this is not, I mean, we're getting there, is we want to make this data that we're looking at, we want to make it as normal as possible. So we're going to start standardizing so that our mean is at 0. And we have 1, 2, and 3 standard deviations from the mean. That's exactly how we want it to work. So that's our goal. What?
Why are we using for the spread? Like, why are we using standard deviation instead of like range?
Okay, because we want to normalize it, which makes it symmetric. So when you standardize, you change your data from whatever it is to a normal distribution. So that normal distribution now has a 0 and a 1, 2, 3, a mean of 0 and a standard deviation. So when it's normal, mean and standard deviation. When it's skewed, it's going to be the other, median and range, IQR, whatever you use. So again, we're kind of jumping the gun. It's going to lead into how do we make this from the data, okay? We're going to change all our scores. All right. I have your questions posted. I'm going to stop sharing and stop recording.